When we find life on Mars, will we move there? The complete guide to our red planet future. The discovery that changes everything. 3 days ago, NASA dropped a bombshell that could change human history forever. They announced that a rock sample collected by the Perseverance rover contains what might be the strongest evidence of ancient life we've ever found on Mars. This isn't just another maybe or possibly. This is the closest we've ever come to proving that life once existed on the red planet. And if life existed there before, could we be the ones to bring life back to Mars? Today I'm going to show you exactly what happens when we confirm life on Mars and how it will trigger the greatest migration in human history. By the end of this video, you'll know not just if we'll move to Mars, but how we'll live there, what we'll do there, and why some experts believe the first Mars babies could be born within the next 15 years. The breakthrough. What we just discovered. Let me tell you about a rock that might rewrite every biology textbook on Earth. Last July, NASA's Perseverance rover was exploring an ancient riverbed in Jezero Crater when it spotted something extraordinary. A rock covered in what scientists call leopard spots, patterns that on Earth are created by chemical reactions that fuel microbial life. But here's what made scientists' hearts skip a beat. When they analyzed the sample, they found organic compounds alongside mineral signatures that suggest ancient microorganisms might have been processing energy exactly like bacteria do on Earth today. Acting NASA Administrator Sean Duffy called it the closest we've actually come to discovering life on Mars. We're talking about life that existed potentially 3.8 billion years ago, when Mars had flowing rivers, lakes, and maybe even oceans. This wasn't just a dead rock floating in space. Mars was a living world. And if life existed once on Mars, the big question isn't just whether it could exist again, it's whether we should be the ones to make it happen. The trigger why life discovery changes everything. Here's something most people don't realize. The discovery of past life on Mars is like pulling the trigger on the biggest space race in human history. Within 72 hours of NASA's announcement, both SpaceX and NASA updated their Mars timelines. Elon Musk announced that SpaceX is now targeting 2026 for the first uncrewed Starship missions to Mars, just 14 months from now. Not 2030, not sometime in the future, 2026. If those missions succeed, the first humans could land on Mars by 2028. But here's what's really game-changing. Life discovery doesn't just mean we can go, it means we must go. Think about it. If we found evidence of ancient microbial life, what are the chances that life still exists somewhere on Mars today? Mars has underground water systems, seasonal methane releases that suggest active biological processes, and protected subsurface environments where life could still be thriving. The discovery of ancient life basically proves Mars has all the ingredients for current life. And that creates the ultimate race against time. Every mission to Mars risks contaminating the planet with Earth bacteria. If we're going to study Martian life, we need to do it fast, before we accidentally destroy the evidence with our own presence. The plan how we'll actually get there. Let me break down exactly how the first Mars colonies will actually happen, because it's way more organized than most people think. Phase 1, the cargo missions, 2026 to 2027. SpaceX plans to send 5 to 10 uncrewed starships to Mars in 2027, 2026, each carrying 100 to 150 tons of supplies. We're talking about nuclear reactors for power generation, water extraction equipment, 3D printers for construction, greenhouse modules for food production, fuel production plants to make methane and oxygen from the Martian atmosphere. Here's the brilliant part. Before humans even leave Earth, robots will have already built the basic infrastructure. NASA's MOXIE experiment already proved we can extract oxygen from Mars's atmosphere. Scale that up, and the fuel for their return trip home will be waiting when the first astronauts arrive. Phase 2, the human landing, 2028 to 2031. The first human mission will be 4 to 6 people, probably staying for 26 months. That's how long they have to wait for the next launch window when Earth and Mars align properly. These aren't tourists. They're engineers, doctors, geologists, and biologists. Their job is survival and expansion. Within their first year, they need to establish a permanent habitat, set up life support systems, begin large-scale resource extraction, confirm the safety and viability of long-term settlement. But here's what's really crazy. By the time the second crew arrives in 2031, the first group will have already expanded the colony to support 20 to 30 people. Phase 3, the migration begins, 2035 to 2050. This is when it gets wild. SpaceX estimates that by 2035, they could be launching 3 to 5 starships to Mars every launch window. That's every 26 months. Each ship carries 100 people. Do the math. That's 300 to 500 new Martians every 2 years. By 2050, Mars could have a permanent population of 5,000 to 10,000 people. That's not just a research outpost. That's a city. Life on Mars. What daily existence actually looks like. Okay, let's get real about what life on Mars actually means. Forget the Hollywood version. Here's what your typical day would look like as a Mars colonist. Morning routine, Mars Sol, 24 hours, 37 minutes. You wake up in a pressurized habitat that's probably underground or covered with regolith for radiation protection. The first thing you do? Check the atmospheric processors. Mars's atmosphere is 96% carbon dioxide, with an average pressure less than 1% of Earth's. Step outside without a suit, and you're dead in 15 seconds. Your breakfast is probably lab-grown meat, hydroponic vegetables, and protein powder made from processed Martian soil bacteria. You're not just eating food, you're eating a carefully calculated balance of nutrients designed to counteract the effects of low gravity and high radiation. Work day. Everyone has multiple jobs. Here's the thing about Mars, there's no unemployment because everyone's survival depends on everyone else doing their job. You might be mining engineer, extracting water from subsurface ice, processing CO2 and oxygen, mining metals for construction and electronics, agricultural specialists, managing hydroponic farms, developing new crop varieties adapted to Mars conditions, processing organic waste medical officer, not just treating injuries, but monitoring the long-term health effects of low gravity, radiation exposure, and psychological isolation. Construction tech, 3D printing new habitat modules, maintaining life support systems, preparing for population expansion. The crazy part? Most Mars colonists will rotate through all these roles. Cross-training isn't optional, it's survival. Recreation and social life. Here's what nobody talks about. Mars colonists will have some of the most interesting social lives in human history. In a small, isolated community where everyone depends on each other, relationships become incredibly intense and meaningful. Entertainment. Low gravity makes for incredible sports. Imagine basketball where you can jump 12 feet high, or rock climbing on cliff faces that would be impossible on Earth. Mars colonists will probably invent entirely new forms of recreation. But here's the psychological challenge. Communication with Earth has a 4 to 24-minute delay depending on planetary positions. Real-time conversations with family back home are impossible. Mars colonists will develop their own culture, their own traditions, their own way of life that's fundamentally different from Earth. The industries. What Mars colonists actually do for work. Let me blow your mind with something most people never consider. Mars won't just be a scientific outpost, it'll be an economic powerhouse. Here are the industries that will make Mars colonists wealthy. Resource extraction. The new gold rush. Mars has massive deposits of rare earth metals that are running out on Earth. Iron oxide, that's what makes Mars red. Titanium, aluminum, and potentially platinum group metals that are worth millions per kilogram back on Earth. But here's the kicker. Launching materials from Mars is 100 times easier than launching from Earth due to lower gravity and no atmosphere. Mars could become the supplier of raw materials for space construction throughout the solar system. Biotechnology, life adapted to Mars. Remember that potential Martian life we discovered? Mars colonists will be at the forefront of astrobiology, developing new medicines, materials, and biotechnologies based on organisms adapted to extreme environments. Earth-based pharmaceutical companies will pay billions for research conducted in Mars' unique environment. Low gravity affects protein folding. Radiation exposure creates new cellular repair mechanisms. Mars medicine could revolutionize healthcare on Earth. Energy production. Powering two worlds, Mars will master energy technologies that Earth desperately needs. Compact nuclear reactors, ultra-efficient solar panels designed for dust storms, and energy storage systems capable of surviving temperature swings from plus 70 degrees Fahrenheit to minus 195 degrees Fahrenheit. These technologies, perfected on Mars, will transform Earth's energy infrastructure, space tourism, and transportation. By 2040, Mars tourism will be a massive industry. 2-year trips to Mars, low-gravity sports, tours of the ancient riverbeds where life once existed. Mars will be the ultimate adventure destination for wealthy Earth tourists. But more importantly, Mars becomes the launching pad for asteroid mining and expansion to the outer solar system. Jupiter's moons, Saturn's rings, the asteroid belt. Mars is the perfect staging ground for the true expansion of human civilization. The challenges. Why Mars settlement isn't science fiction anymore. Let's be honest about the problems, because they're real and they're scary. Radiation, the silent killer. Mars has no magnetic field and almost no atmosphere. That means constant bombardment by cosmic radiation and solar particles. A Mars colonist will receive about 100 times more radiation than someone living on Earth. The solution? Underground cities, advanced materials that block radiation, and possibly genetic modifications to improve radiation resistance. We're not just moving to Mars, we're evolving to survive there. Medical emergencies. No emergency room on Mars. Appendicitis on Mars? You better hope your colony has a trained surgeon. The nearest hospital is 140 million miles away. Mars colonies need to be completely medically self-sufficient from day one. This means surgical robots, AI diagnostics, 3D printed organs, and medical training for every colonist. Mars medicine will be decades ahead of Earth medicine by necessity. Psychological isolation. The Mars mind. Here's what Mars colonists won't tell you in their video calls home. The psychological effects of permanent settlement are unknown. No human has ever lived more than 437 days in space, and Mars is psychologically more isolating than the International Space Station. Mars colonies will need psychologists, social programs, and probably new forms of therapy designed specifically for permanent off-world settlement. The first generation of Mars colonists will be psychological pioneers as much as space pioneers. The transformation. How Mars changes humanity. Here's the part that gives me chills. Within 20 years of permanent settlement, children will be born on Mars who have never breathed Earth air, never felt Earth gravity, never seen a blue sky. The Mars generation kids born on Mars will be taller, have larger lung capacity, and be adapted to low gravity. Their bones will be different. Their cardiovascular system will be different. They'll be the first true Martians. But here's what's really incredible. They'll think differently too. Growing up in a small, interdependent community where everyone's survival depends on technology and cooperation will create a fundamentally different psychology than Earth-raised humans. Two worlds, one species. Within 50 years, we'll have two distinct branches of human civilization, Earth humans and Mars humans, with different cultures, different capabilities, and different perspectives on what it means to be human. This isn't science fiction. This is the inevitable result of biological adaptation to different environments. Mars colonists will be the first step in human evolution beyond Earth. The bigger picture, why Mars is just the beginning. But here's the real mind-bender. Mars isn't the end goal, it's the training ground. Everything we learn about living on Mars applies to Europa and Enceladus, Jupiter and Saturn's ocean moons, Titan, Saturn's moon with lakes of methane, the asteroid belt, unlimited resources and low gravity. Eventually, other star systems, Mars colonists will be the ones who figure out how to build generation ships, how to maintain human civilization across interstellar distances, how to adapt to alien worlds. The discovery of ancient life on Mars isn't just about Mars. It's about proving that life exists throughout the universe, and that humans can be part of that universal story. Two worlds, one species. Within 50 years, we'll have two distinct branches of human civilization, Earth humans and Mars humans, with different cultures, different capabilities, and different perspectives on what it means to be human. This isn't science fiction. This is the inevitable result of biological adaptation to different environments. Mars colonists will be the first step in human evolution beyond Earth. The bigger picture, why Mars is just the beginning. But here's the real mind-bender. Mars isn't the end goal. It's the training ground. Everything we learn about living on Mars applies to Europa and Enceladus, Jupiter and Saturn's ocean moons, Titan, Saturn's moon with lakes of methane, the asteroid belt, unlimited resources and low gravity. Eventually, other star systems, Mars colonists will be the ones who figure out how to build generation ships, how to maintain human civilization across interstellar distances, how to adapt to alien worlds. The discovery of ancient life on Mars isn't just about Mars. It's about proving that life exists throughout the universe, and that humans can be part of that universal story. The timeline, when this all actually happens. Let me give you the realistic timeline based on current technology and funding. 2026 to 2028. First uncrewed cargo missions establish basic infrastructure. 2028 to 2031. First human landing. Permanent outpost established 2031 to 2035. Colony expansion to 50 to 100 people. Basic industries operational 2035 to 2040. Regular passenger service. Population reaches 500 to 1,000. 2040 to 2050. True city established. First Mars-born generation reaches adulthood. 2050 plus. Mars becomes economically independent, launches missions to outer solar system. The wild part? Most of you watching this will live to see human cities on Mars. This isn't some distant future. This is happening in our lifetime. The choice. Why some will go and others won't. So who actually goes to Mars? Here's what the selection criteria look like. Physical requirements. Perfect health, age 25 to 45, no major genetic disease risks, excellent cardiovascular fitness, psychological profile, high stress tolerance, collaborative personality, problem-solving skills, emotional stability, skills, multiple technical specialties, leadership experience, teaching ability, commitment, willing to stay permanently or at minimum 4 to 6 years. But here's what's really interesting. As Mars colonies become established, the requirements will change. By 2040, Mars might be accepting immigrants who are older, less physically perfect, or simply looking for a completely different way of life. Mars will evolve from an extreme frontier to a legitimate alternative to Earth life. Conclusion: the most important decision in human history. Let me leave you with this thought. The discovery of ancient life on Mars means we're not just exploring space. We're joining a universe where life exists beyond Earth. The first humans to set foot on Mars won't just be explorers or scientists. They'll be the founders of the first human civilization beyond Earth. They'll be the ancestors of Martians who might one day look back at Earth the way we look back at the villages our great-grandparents left behind. In 50 years, there will be children on Mars who dream of visiting Earth the way we dream of visiting Mars today. There will be Martian poets writing about red sunsets and low-gravity dancing. There will be Martian engineers designing spacecraft we can't even imagine. And all of it starts with the decision we make right now. Do we take the discovery of ancient Martian life as a proof that we belong out there among the stars? What do you think? Are you ready to be part of the generation that makes humanity a multiplanetary species? Let me know in the comments if you take a one-way ticket to Mars. And don't forget to subscribe, because we're going to be covering every major development in the Mars colonization story as it unfolds. The future is coming faster than anyone expected. The question is, will you be watching it happen, or will you be part of making it happen? Thanks for joining me on this journey to humanity's multiplanetary future. See you in the next video, and maybe someday, see you on Mars.